everyone, we're going to use series to approximate the definite integral to 4 decimal places. We have sine x to the power of 4 dx there. All right, so we're going to use the Maclaurin series for sine. And if we look at sine of x, and that's going to be the sum from n equals 0 to infinity, negative 1 to the power of n times x to the power of 2n plus 1 divided by 2n plus 1 factorial. Now I'm just looking at this. So if we use sine of x to the 4th power, that's going to be the same thing, but for x we have x to the 4th times 2n plus 1, and that's just going to give us x. Let's write this out. We're going to get the sum n equals 0 to infinity, negative 1 to the power of n. This is going to be x to the power of 8n plus 4 divided by 2n plus 1 factorial. All right, now let's just integrate this. So we're integrating this whole thing. So the integral of sine of x to the power of 4 dx equals the integral of this, which gives you c plus the sum n equals 0 to infinity. We have negative 1 to the nth power, and then for this piece here, that's going to be your x. So you have x to the power of 8n plus 5 divided by 2n plus 1 factorial times our exponent here, 8n plus 5. All right, so that's what that is. Now we have to do the definite integral, and we're evaluating it from 0 to 1. And when you do that, what's going to happen is the denominator is going to disappear. So what we're going to get is the sum n equals 0 to infinity of negative 1 to the nth power divided by 1 divided by 2n plus 1 factorial times 8n plus 5. Okay, that's after we evaluated from 0 to 1. Now, let's go ahead and expand some of this. If we expand it, this is going to equal, starting at 0, we're going to get 1 divided by 1 factorial times 5. Then we're going to have minus 1 divided by 3 factorial times 13 plus 1 divided by 5 factorial times 21 minus 1 divided by 7 factorial times 29 plus dot dot dot. Now we have to do our estimation. So if I do the first 3 terms, I'm going to get, and I'm using my alternating series estimation theorem. So let's look at the first 3 terms. This part here is going to be approximately 0.18776. Now, subtracting this part, now this part right here is going to be 6.84 times 10 to the power of negative 6. So if you subtract this from here, it doesn't affect the 4 decimal places. So by the alternating series test, estimation theorem, our answer is going to be here, 0.1876. Thank you. Have a nice day. Bye-bye.